Lamport's mutual exclusion algorithm. Lamport's mutual exclusion algorithm is a permission-based algorithm proposed by Lamport as an illustration of his synchronization scheme for distributed systems. In this algorithm, three types of messages are used, namely request, reply, and release, and communication channels are assumed to follow FIFO order. A site sends a request message to all other sites to get their permission to enter the critical section. A site would send a reply message to requesting site to give its permission to enter the critical section. A site would then send a release message to all other sites upon exiting the critical section. Every site S keeps a queue to store critical section requests ordered by their timestamps. Request_queue denotes the queue of site S. A timestamp is given to each critical section request using Lamport's logical clock. Timestamp is used to determine priority of critical section requests. Smaller timestamps gets high priority over larger timestamp. The execution of critical section requests is always in the order of their timestamp. Algorithm. To execute the critical section, a site S can enter the critical section if it has received the message with timestamp larger than timestamp I from all other sites and its own request is at the top of request_queue. To enter the critical section, when a site S wants to enter the critical section, it sends a request message, timestamp to all other sites and places the request on request queue. Here, timestamp denotes the timestamp of site S. When a site S receives the requests from site S, it returns a timestamp reply message to site S and places the request of site S on request queue. To release the critical section, when a site S exits the critical section, it removes its own request from the top of its request queue and sends a timestamp release message to all other sites. When a site S receives the timestamp release message from site S, it removes the request of site S from its request queue. Message complexity. Lamport's algorithm requires invocation of 3 N1 messages per critical section execution. These 3 N1s, a message involves N1 for request messages, N1 for reply messages, and N1 for release messages. Drawback of Lamport's algorithm. Unreliable approach. Failure of any of the processes will halt the progress of the entire system. High message complexity. Algorithm requires 3 N1 messages per critical section invocation. Performance. Synchronization delay is equal to maximum message transmission time. It requires 3 N1 messages per CS execution. Algorithm can be optimized to 2 N1 messages by omitting the reply message in some situations or by removing or excluding the reply message situations.